Hello and welcome to today's webinar, Manufacturing Workflows and Technology. This webinar is brought to you by Live Lab Learning, which is a subsidiary of Academic Corporation, a wholly owned applied software company created to provide world-class training. This is Marcia Tucker and I'm delighted to be your moderator today. Throughout our presentation, we encourage you to interact with us by typing in questions and comments using the questions pane, on the right-hand side. We will be answering your questions at the end of the presentation. This webinar is being recorded and you will receive via email the link to the recording. And we will be, if you could go back to this first slide, gentlemen. My apologies. We have connected workflows and we have upcoming webinars and events. If you would subscribe to our channel, YouTube, and once you get to the YouTube channel, if you would search Live Lab Learning in all one word, then you will be taken to a list of webinars we've done in the past. Also, when you visit Live Lab Learning, you will be able to see upcoming remote live training classes that we have, and we have a breadth and depth of knowledge in all of our divisions, whether that be manufacturing, architects and engineers, or our construction division. So again, that's Live Lab Learning. Some upcoming events: we have the Georgia Manufacturing Summit at the Cobb Galleria Center there in Marietta in northern Atlanta on November the 18th. And also, hopefully some of you have signed up for Autodesk University, an exciting time to garner a lot of knowledge. That's December 1st through the 3rd in Las Vegas. And my information and contact is at the bottom. It's mtucker@asti.com. Our next webinar that we're going to have, which is the second release of Inventor 2016, is going to be November the 19th from 12:30 to 1:30, and that is always Eastern time that we're referencing there. So it's going to be incredible innovations with Inventor, so please sign up for that. And we have two of our highly trained technical staff today presenting. We have Scott Hallmark and Jason Miles. So right now I'm going to turn it over to Scott. Thank you very much.
All right, great. Thank you, Marcia. So yes, we are going to be looking at some workflows dealing with some of the new features that you'll see in Inventor 2016, as well as Nastran, In-CAD Nastran, and some other things. So what we'll do is real quickly we'll take a look at some of the I guess the data that we're going to be working in today. So what we're going to be doing is we're going to be making some changes to a bell crank assembly as part of a BAC mono vehicle. The bell crank assembly is from Briggs Automotive Mono. So we'll jump over here to our Inventor and take a look at what we're going to be looking at today. So really, this bell crank assembly that you're seeing right here is what we're going to be making modifications to. We want to lighten it up a little bit, and so we're going to be using some of the new tools inside of Inventor, as well as, like I mentioned, using Vault Pro and Nastran In-CAD in order to optimize this component. So that's what we're going to be working on, that assembly. So, but in order to do this, we're going to need to take a look at our Vault and see in here what we're going to be needing to do. So in here you can see I'm logged into to our Vault Pro Explorer, and in this we've got our list of files and folders that are part of this Vault, but also you'll see down here in my work list I've got this ECO, or an engineering change order, and in that engineering change order we can see certain things about this particular change that we need to make in here, like a detailed description that's written here regarding this bell crank assembly. and that it says, please review the attached Nastran simulation report. That's a PDF file that has been attached to this ECO. This part is heavily overbuilt, and we need to consider a redesign with the goal of reducing weight by 20%. So that's what we're needing to do. So if we want to go and take a look at the file that's been referenced here, we'll go over to Files, and we can see that there are some attached files. Whoever generated, the engineering manager that had generated this engineering change order, this ECO, has attached the assembly, the drawing, and the Nastran report. So we just need to take a look at the Nastran report. So what you're looking at is actually an actual report created from our Nastran In-CAD application from Autodesk. So what I'm really interested in, we could go through and we could read all this, but what I'm really interested in is the information down here at the bottom that's telling me what I need to do, which is letting me know what the current safety factor is of this component and of this front rocker, which is a part of this bell crank assembly, and we need to lighten it up and by 20%, but at the same time remain above a safety factor of 2.0. So that's the goal, and so in order to do this, we need to take a look at the assembly. So you can do a preview here just to kind of look at it and roll it around inside of Vault. So I'm not actually an Inventor at this point. I'm just inside of the Vault, the data management tool, and I can see what I'm going to be working on. If I want to go to that folder and just start working on it, then I'll just go to the folder and take this assembly, and I could manipulate this very assembly, but what I really need to do is just do a copy design. I need to use another tool inside of Vault Pro that allows me to take a design of components and subassemblies and make a brand new version of it. And so that's what I'm going to do with this. I'm going to take this assembly, this bell crank assembly, and I want to do a copy design of it. So you'll see what it does is it goes out and it finds all the children that we need in order to make our new change, our new copy. So obviously I want to make a new copy of the overall assembly, but the part that I'm going to be modifying is this front rocker. So I can see the description here that's been put in from the part level, and so I can take those and I can just simply copy those. And what it's going to do is it's going to go in and make a brand new par file for me. So if I stretch this over, we'll take a look at what we have here. This is the old name. You see these pound signs here. That's the new incremented number that's going to be assigned to this part. So I'm not having to go look up a sheet of paper or a booklet or notebook and find out what my next available number is. A Vault's going to handle that for me. And so I just need to tell it what functional category this belongs to. Well, it's part of the front suspension, so I'm going to change that, and you'll see how this naming scheme is going to change based on changing that functional category. So once I have that in place, I'm ready to copy. It's a fairly simple process. I'll create a copy of that, and it's going to make those copies, and I'm basically reusing everything else. These items do not change, so I don't need to make copies of those. I want to reuse data. That's one of the powerful things of using Inventor and Vault is being able to reuse your data. So I'm going to scroll down, and you can see there's 5 new files that were created here. A new part file, a new drawing file of that part or a detail, a new presentation file or exploded view, an IAM file was created from that single copy design, and then the overall DWG of that assembly as well. So or the detail. And so what we need to do is we need to get this and check these out, because these are the ones we're going to be working on. So we'll get those and check them out. Now a little bit later on, Jason, who's also my counterpart at Applied, is going to be taking this very part and running it through. After I make my modifications, he's going to take it and he's going to put it through Nastran In-CAD and make sure that it's going to be functional for what it needs to do for this BAC mono. So there'll be some work that he's going to do inside of Nastran In-CAD. He's going to be doing some work inside of AutoCAD Mechanical as well. So he's going to be able to take a design that you're going to see me use in order to create this new part, and then he's going to be able to manipulate that part on his end in AutoCAD Mechanical and actually update the part file. So now that we have these files ready and checked out to me, we'll just jump over here into Inventor. And so this is the old assembly and the old part. So what I need to do now is basically work on that new one. So I could go and back into Vault and do an open from there, which is probably the easiest thing to do. So we'll just go and open that file. And you can see it open right there in this session of Inventor. And so what I need to do is work on this front rocker. So I'm going to double click on this to activate it, right? So we can see where you still see the assembly itself, but I'm in part mode. So I really don't need all this information that's here. You can see that there was a body created, direct edit. So looking at this, I can tell that this was pretty much imported in from something else. It could have been imported in from another 3D application. There's no real history here except for some direct edits that were made. But I want to create a brand new one. So I'm going to take this into part and drag it up, and this is where I'll create my new part. So like I mentioned, I've got this AutoCAD drawing that has this exact design that I need to put in place. So I'm going to go over to the Manage tab, and we'll import that DWG. So now we're using a new feature that's inside of 2016 called Dwg Underlay. And so what it does, it allows me to take an AutoCAD file. If you're familiar with AutoCAD X-referencing, it's very similar. I'm able to X-ref or reference this file into my model and then use geometry off of that drawing in order to create a 3D solid. Now the unique thing about this is that it's still referenced to the drawing, so if someone was to open it up in AutoCAD, they would be able to manipulate it in AutoCAD and have the 3D model automatically update. So this is the model that or the drawing file that we're dealing with. You can see it's got a border and all that good stuff on it, but I'm not really interested in dimensions or borders or anything like that, so I'm going to go in and I'm going to change the layer visibility. This actually does read the AutoCAD layers from the AutoCAD drawing, and so I'm really interested in just a few of these, or a couple of these layers, the visible layer and the hidden layer. So instead of unselecting all these at one time and then going back and selecting, I'll just do an inverse and turn on just the ones that I need. And so there's the components or the geometry that I need. I also want to translate this, meaning I want to move this from one location to the other. So I'm going to locate the center of this hole and snap it to my origin point. That way it moves that geometry, and really all I need to do now is project some geometry and extrude it. So that's a really simple process to go through. And so now what we'll do is we'll go in and we'll extrude, or actually we need to create a new sketch, and then we'll extrude that geometry. So we'll create a sketch on that same plane that I just placed this on. And I'm going to go in, and so I don't want to necessarily use just project geometry. I want to project DWG geometry. That's going to allow that referencing to remain intact, right? So when I start to select these, I want to turn on some loop selections first and get some of these, so I don't have to pick all these fillets and edges and corners like that. So I just want to get a couple of these that will grab the loops. And then I want to change it over to just a single selection so that I can get this one here, because I don't want it to go all the way around and pick this side as well. So you'll see that as we go in and start extruding why that's important. And then I'm going to project a couple more in here that we're going to use a little bit later in order to define the location for the bearing that would need to be put in here. There's a couple more that I need to project, and so as I project these, I'm going to come back and dimension these. And the reason I'll dimension these is I'll be able to use those reference dimensions in order to define my extrusions. So, you know, when I go to dimension these, it's obviously going to tell me these are reference or driven dimensions. They're driven by the sketch. or by the reference geometry. So I'll place these in, and I'm really not concerned with naming these. I could go back into the parameters and name those if I wanted to actually give them names. But that's really all I need to project at this point. So I'm taking existing geometry from a DWG that is referenced in as a DWG underlay. So it is still reading the actual DWG. It's not a copy of it. So now we'll go and extrude this. I want to extrude this main solid here and a couple of these profiles so I can see this part start to be created. Now as for the extrude distance, that's where we go back and we use some of this existing geometry and driven dimensions. So you can see that it's going to read that value, and I just want half of that because I'm actually going to do some work to this, mirror it in order to create this part. So I'll take that existing dimension in order to create that extrusion. We'll create another extrusion here. Actually, after we turn on the sketch again, we don't have to share the sketch. It just turns it on, or it makes it available for sharing if we just turn on visibility and create a new extrude. That's a really nice feature here that allows us to do that. So again, I'm just going to highlight that dimension, and I'm going to select the new cut, which would be this 24.36, and divide that by 2. You can see how it's cutting into the part. We'll come do this other one over here as well, this larger profile, and again, I'm just going to take out that dimension, select the 22.33, divide that by 2. That's going to give me that cut, and we will finish off with this one here. And same process, we select that dimension and let it create the cut. So I've got my cuts created, my features are created, my solid is created. I've got just a little bit more to do back here, but there's some cleanup I need to do. So I'm going to turn off my sketch. We'll turn the visibility off of it. We'll turn the visibility off the drawing. We're going to come back to this a little bit later. I need to add some fillets in. So the first radius I'm going to be dealing with is a 7 millimeter. So I'll just pick the edges that they're going to get this 7 millimeter fillet, and then I need to add another one that's 3 millimeters. So I'll go ahead and pick it. It's going to be this small edge right here. We'll apply that. And now I need one more that's just 1.5 millimeters, and it's going to be these inside edges here. And by doing this now, this allows me to go ahead and have that as a part of my mirror when I do the opposite side of this. So we'll apply this, and now we need to add a new cut to this. If you look at this from the side, this is actually these are parallel faces here, and what I need to have is actually a conical cut that's going to kind of shave some of this off from the top. So I need to create a new sketch in order to do this. So I'm going to use one of my default planes that's cutting right through that part, the XZ plane. And so we'll roll it a little bit here so we can see what we're drawing. And I want to project the edge of that face. And I'm just going to draw some geometry in here that will help us to, we'll put in a dimension of 160. And then we'll draw one more line that's going to be horizontal to that line. So I'm looking for that 90 degree, there it is, 90 degree line. All right, and now since I've got this sketch in here, I need one more dimension. I need to define the angle of the conical cut. So we'll put this in as 86 degrees. All right, so now we're ready to do a revolve cut of this. So notice I don't have a closed profile here. I just have a couple of sketch lines. This is actually a really nice feature now that we can just pick the profile. It basically gives you an area to pick, even though we didn't have a closed profile to cut out. And then I'll pick the Z-axis, which is the vertical axis, as my rotation axis. And so we are cutting that, so I change it to a cut. And so now you can see that I have a conical cut on that part, exactly where I need it, and that's perfect. So, so now I've got that in place. I'm ready to do one more thing here, which is come in and add that extra material to the inside. So in order to do that, it's kind of hard to see it here with material in front and you know this component here. So what we'll do is we'll change our view so that we can see just a half section of this. So I'll pick one of those planes to where I'm seeing just a half section of that. That allows me to be able to pick the exactly the plane that I need when I go to create these. So I told you we were going to need this sketch a little bit later, so I'm going to turn it back on. And so it's automatically shared. I'm just ready to extrude now. So I'll pick the profile, and we'll tell it the distance that it needs to go. So I'm just going to highlight that and then tell it that we're going to this face and that we're joining, we're adding material. So you can see what it's going to create. It's going to add that material up to that face, which is exactly what we need. And I'll do the same thing again on this profile. Again, that's going to be a join, and we're going to a certain face. So this depth option is actually giving me the ability to apply rules basically to this, if anything were to change on this part or assembly here, then this would automatically update. Okay, so we've got that in place. Now I'll just do a return, and we'll go back to our view and go back to a full section or an end section view so I can see everything. So now I'm ready to mirror this. I've got everything created there that I need to create, and so I'll just mirror this solid. So we'll go back into the part, and we'll mirror. And I want to do everything. I don't want to pick each individual feature. I want all the fillets to mirror. I want all the cuts and everything else to mirror as well, and the newly added features inside of here. So the mirror plane is simply going to be that face. And so now we have our part created. Very simple process, and new features in Inventor help make this easy and very possible to do. So we'll return, and now I want to look at our drawing for this particular assembly. So I'm going to open this drawing and take a look at it. So you can see that it's automatically reading the new geometry. It's showing my cuts in there. It's showing the conical cut I had here. The IPN that was also part of that copy design has also been added. So the view from that IPN is showing up here in my exploded view. And so we'll use that exploded view to create our balloons and our parts list. So I'm just going to select that geometry, place the balloons, and let it point to the individual items. And then we'll go place a parts list, and then we will be done with this drawing. So I'm wanting it to pull all the components off of that view, and there's our parts list with our ballooned items as well. And so there's the new part number we just created, 1145, and there's the front rocker. So this is the new version, the new drawing for this assembly. So now I'll go back, because we were going to be working in here, right? We need to actually replace this component with the new rocker assembly that we just created. So since this is a sub-assembly inside the top level assembly, it's going to be a simple component replace. So we'll go find component, replace, and then I want to go find that new assembly, which will be 1144. Now the thumbnail has not updated because I didn't actually hit save, but because we are dealing with Inventor, when I go and place this in, it's going to ask me to check it out, check out the overall. There's the new assembly, and exactly as it should be. Now I could go back in and if these arms here were not fully constrained, I could go back in using the joint command, using the ball constraint, and put those back in. And I can do that while Jason is now doing the work he needs to do on his part as well in CAD Nastran. So I'm going to send this over to Jason and let him take over.
All right, thank you, Scott. So we can see here on my screen the assembly that Scott was working on. And like Scott mentioned, what we're wanting to do is we're wanting to run some simulation on this particular part. So I'm going to go ahead and we're going to start with this part, and you'll notice that I am in Autodesk Nastran 2016, and you'll notice that I'm still directly within Inventor. Now we're going to start out I want to start out by constraining this part as it is in our current suspension assembly. So we'll start out by adding some constraints. And then also, we want to go ahead and set up some loads that this particular rocker is going to be seeing when it's in our assembly. So we're going to add some loads with the load from the push rod through these two holes here. And I'm going to set this up to be, let's go with somewhere around 500 newtons. So I want to make sure that I have the direction that this force is going to be pushing on, pointing in the right direction. And we can see the direction that my force is going to be going. All right, so after we have that, I have the ability within Nastran to use some special kind of constraints. So I'm going to go in and I'm going to create a new connector. And with this, I'm going to actually utilize that sketch that Scott was using to produce his geometry. So this particular part is actually going to be able to, it's going to be able to rotate a little bit within this area here. So we wanted to incorporate the forces on this inside circular face. So that's what we're going to be having. Like so. So that's the forces that we're going to see coming in there. And then also, since this is going to be able to rotate, I need to tell Nastran that that particular degree of freedom, which is going to be my Z, I need to uncheck that where it does have that capability to rotate. So I need to release that rotation. Okay. So I'm going to select that projected point once again, and you'll notice here I got a revolution in my Z, so I'm going to uncheck that. All right, so with just a few clicks and adding some constraints and loads, we're actually ready to go ahead and generate our mesh. It just gets it ready to where it can perform the calculations, and then after that we're ready to go ahead and run this. Now the great thing about Nastran, and I'm sure Scott would agree, is we're actually able to do this testing without creating, prototypes and then testing each prototype and then coming back and making modifications. We're doing this live, and this just actually, it speeds up time, like I said, with cutting out the prototypes. And not only that, it also saves us cost on our material that we would have to use to produce those prototypes. Now, so since it's went ahead and finished, the first thing that I want to do is I want to take a look at the stresses that were generated. So we'll see that I have a peak or a max here of right at 138 megapascals, okay? This isn't critical, but we want to try to get the best design out that we can. So we're going to try to reduce this a little bit. Now, with what Scott mentioned in regards to the document attached to the ECO with the results PDF that he showed, our main thing that we want to do is not only has Scott already reduced some of the weight of this part, but we want to pay attention to our safety factor. We're trying to keep it around 2. So I'm going to go in and I'm just going to go ahead and set this to 10 just to show me the max there. And let's see what we have. All right, currently you'll notice that we have met our minimum factor of safety, so we're a little over 2, so we're 2.21. Okay, so with that being said, we want to go ahead and take this a little bit further. So I want to actually set up another analysis. And this analysis that I'm going to set up is, it's going to be a fatigue analysis. And I'm going to go in and I can modify this and go ahead and call this fatigue. All right, and you notice I set the type to multi-axial fatigue. All right, so since I made a copy, I can just go in and modify some of the loads and constraints that I've already set up. So the first thing I'm going to do is I'm going to modify, or actually go in here, I want to take a look at something right now. So with this, what I'm capable of doing is I'm just going in and I'm evaluating the design of my part as it is right now. And I want to just looking at my XY plot, because what I really want to do is I want this part to be able to survive an entire season of racing. Okay, so ideally what this season would look like would probably be around 8 or 9 races. So I'm going to go in and just do some more modifications, just setting up my fatigue. So I'm going to go in and I'm going to put in a time conversion factor here. Okay, so once we have that, that's the only 2 things that I wanted to change. Let's go ahead and generate the mesh once again. And then we will run it. Now, whenever this finishes, like I said, we're wanting to see the life of this part. So whenever this gets done, I'm going to have another analysis that I can look at, or a result that I can look at, and you'll notice that I have a life contour. So with this, go ahead and do some filtering here so I can really see that life contour. Now you can imagine we're doing 8 or 9 races, and you can expect that this part is going to see a lot of stresses. Okay, so the great thing about doing this, once again, just to reiterate what I mentioned before, is that, you know, Nastran In-CAD allows us to evaluate this part without having to build a physical prototype. And if, you know, if we, or I would say it would also limit the physical prototype too, okay, or the amount of physical prototypes that we have to create. Now, even though Scott's design here, it's a real good design, but Scott and I always try to, you know, see what we can accomplish and getting a great product out by utilizing this software. So what I want to do is I'm going to go ahead and finish my Nastran, and like Scott mentioned, he's already updated the CAD drawing. So I'm going to go over to mechanical, and you're going to notice that we're utilizing Autodesk Vault. And within mechanical, I can actually work with the Vault directly here inside of AutoCAD Mechanical. So I'm going to go ahead and I'm going to open from the Vault, and I'm going to open up that drawing that he was utilizing. And we're going to make some modifications. So here, I'm going to go in and modify some of this geometry. And within here, and Scott, if you agree on this, I think maybe we can possibly minimize this opening just a little bit, give them a little bit more material, because we knew those hot spots that I were having shown in Nastran were somewhere about in here. So I'm going to go ahead and just stretch that up a little bit. And I'm going to say probably, this is, we're in the design process, so I'm going to start out and let's do 10 millimeters. So you notice I've made those changes. There was, I just isolated the geometry that was on this layer, and I just undid the isolate right here in Mechanical. So now that I have that, I'm going to go ahead and save this. And once that's saved, let me turn that off real quick. Save it and go ahead and close it. And what we're doing, remember, we're using that, or I'm using that, that Dwg Underlay. So once I make those modifications and go straight back to Inventor, we'll give it a second to update, and notice that I have a lightning bolt over here beside of my DWG that Scott utilized to create this part. Now, I'm going to rotate this just a little bit so you can notice whenever I hit the update that this part is going to change. Okay, notice there, our part has changed. Now, there's a few other things here possibly that we could do. Like I said, we're still in the design process. So what I want to do is maybe we go in and add maybe just a little bit of material here on these cutouts, almost like if I was placing in a rib for some support. So since Scott created this part utilizing the mirror, I'm just going to move my end of part up above that mirror. So we're just working on half, because whatever I create now and then move that end of part down, it's automatically going to be mirrored to the other side. It will be included in that mirror. So somewhere around probably about 5 millimeters, that should be sufficient enough. Okay, and then once I have that, let's go ahead and move that back down. Okay, everything looks good. Now, once I have this, I'm going to go ahead and turn that visibility off of that sketch. Now, you'll notice I'm going to go ahead and save this part. Now, just for the sake of time, we could go back and go through the process again, going back to Nastran In-CAD once these changes are made, run our analysis again, and then we could compare results. It's just all part of the design process. So you'll notice, let me go ahead and update here in this top level assembly, that we have our new part. And since we are utilizing the Vault, just like in AutoCAD Mechanical, I'm able to use the Vault in Inventor as well without having to leave the Inventor interface. So I can switch my model browser to the Vault browser, and you'll notice here that I have the capability of checking this file or all these files back in. Now, usually what I like to do is after making the changes of a design that I'm currently working on, I like to add some kind of comment down here at the bottom, just so we can keep track of what was done. So I'm going to add a comment stating that incorporated changes to the bell crank assembly per that ECO that Scott mentioned, and also the analysis results. So once we have that, go ahead and check all this back in. And you'll notice here, since we have the new Vault capabilities here on our home screen, you'll notice that I did close and delete these from my workspace, so that is what it is saying here. They're no longer there. So usually what I'll do is I'll just unclear those filters there. And then back in the Vault, you'll notice that I don't have anything checked out. So you can see that the workflow that we talked about today, from really the initial design phase, the testing, the data management, how this is a really nice workflow that we are capable to utilize. And especially working within a team, you can see how Scott and I work together to create a pretty good part that I'm feeling pretty good that we'll be able to withstand 8 or 9 races. So with that being said, I'd like to go ahead and turn it back over to Marcia.
Thank you, gentlemen. That was great. Hopefully our attendees enjoyed that. At the present time, if you'd like to type in any questions, we'd be delighted to answer them. And you maybe covered this, but I did have a question from a client that says, when a file is imported into AnyCAD, are the restraints, are they able to fully manipulate the file, or is it just stay as a step file?
They have direct edit capabilities. It's going to come in with without any features. It's going to come in as a base solid. But with Inventor, you do have what is known as direct edit capabilities. You can change sizes, change holes, push and pull, and then you can also create new features on that part if you need to.
Okay, that's great to know. Thank you. Well, if someone's out there typing feverishly, we'll give you a few more seconds, but we do appreciate it. And again, visit youtube.com, and then in the search button, search for Live Lab Learning, all one word, and you'll be taken to all the previous webinars, and this webinar will be posted there within the next 24 to 48 hours, and you will also receive an email with a link in that. And at this time, we've not had any questions. So we would like to thank you for your time. We realize it's very valuable, and thanks for joining us. So have a great day. Bye-bye.